Hello, this is Tor from IDCON. Today we have part number 6 in common mistakes when doing root cause failure analysis. A common mistake is that we develop the possible causes to a problem in an incorrect way. Let me explain first what I mean with this, because it may not be clear to everybody. So as you see here in the slide, that you have a trigger. A trigger for us is typically the reason why we're doing the root cause. In this case, it's a 4-hour production loss. The next box is a problem statement. We talked about common issues with that in video 1 and 2. And by the way, you'll find all these videos down here, right? The links to video 1, 2, 3, 4, 5. And in the future, 6, 7, 8, etc. Now, so we have a trigger and we have a problem statement. Now what happens is, if you look at slide 2, what I mean with develop possible causes is that level after the problem statement. Now you may do a 5Y, you may do a tree of some kind, Apollo, whatever it is you're using as a documentation method. That's just a documentation method. The principle is the same. You have a problem statement and then you start developing possible causes. It's true for all root causes, or should be anyways. Now, when we develop these possible causes, there's a problem that we jump a little bit too far too fast, and that we're not clear on how it's connected to the problem statement. That's really fuzzy. So let me explain that with an example. So slide 3 here, you see a hydraulic system, a very simple one. It has a container, you have a pump, you have a relief valve, four-way valve, etc., etc. And top right, we have a cylinder, a hydraulic cylinder. The problem statement is that the hydraulic cylinder is moving too slow. You can see the evidence there. We have some information, and that's an exercise. I'm not going to go through the whole exercise. But what happens a lot of times is what you see here in this 4th slide, that students that takes this class say, how can it happen? And they start listing components, the pump, the relief valve. And it's true that those things can probably influence what happens with that extension of that rod for the cylinder. But the problem is that we're jumping too fast, too far, number 1, and number 2, that we're not really showing how it's connected to the object and the problem. So if I say hydraulic cylinder is moving too slow and I call it just pump, well, how does that happen? Well, if you're technically good, you probably can think of, well, it could be pump is cavitating. Well, yes, but it can also be the pump is not working at all. It has no power. So it's different with a pump has no power versus it's cavitating. So we're jumping too fast here. We're not explaining what we mean. We're just writing down pump. So this is a very common mistake. And we're not focusing on the object. We moved away from the object. So if we look at this hydraulic cylinder, so we have the 2 problems. The first one is we're moving away from the object. So if we look at the 4th slide here, you have to ask the question, how can the cylinder actually move slow? If you answer that question, it's not pump. That's not a reasonable answer. There's a lot of steps in between that you're leaving out. But we can say there's not enough power to move this cylinder. That's one way. The other one is the restriction of the end of the cylinder, not making a mechanical resistance that's stopping that cylinder from moving. Now you can divide it up in different ways, but you need to stay connected with the object and say, how can that problem happen to that object? And then the next step could be, well, if we don't have enough power to move that cylinder, not flow in this case, well, how can that happen? That's the next step. Well, maybe we don't have enough flow from the pump. So now we start connecting, because if we jump too far too fast, what happens is you haven't developing not possible causes, but you actually jump into conclusions sometimes, and you're guessing a bunch of causes already. So and the other thing is that we need to explain how, not just an object pump. We need to say pump not delivering enough flow. So now we have it. So the rule of thumb is, and when you develop possible causes, have at least one verb and one object explaining how it happens in developing possible causes. Let me show you one more example, because this one is a little bit trickier. Let's look at this. Here's an aluminum plant, and they have this roll, and on that roll there is aluminum, and there's a coated roll. that alumina is slipping on that roll and it's not supposed to be. So the problem statement is that the alumina is slipping on the roll. Now we ask, how can that happen? Very commonly we get answers such as motor. We start listing components again, right? Bearing. And it's not really clear, well, how's the motor going to make that roll slip, we ask. Well, maybe the motor's moving real fast all of a sudden and then really slow. It's like, well, how's that actually going to, is that actually true? I mean, there's a lot of steps between there. So in this case, it's really only one way that aluminum can slip. So if you focus on object and thinking about how can that alumina slip on that roll? Well, if you take a look here, the only thing that can happen is that the friction force is too small. That's how it slips. That's physically how it slips. Now, if you remember from school, what is friction force? I can't remember the exact formula, but it's basically a formula of the normal force on the aluminum and the friction coefficient, those two things. And that could be the next step in developing possible causes. And then we can say, well, how can the normal force be too slow? And then we can start talking about how that can happen. And then we can say, how can the friction coefficient be too slow? And it's too small, and then we can see how we can develop that. So to summarize, first of all, we need to focus on the object in the first level of developing possible causes. That's a very common mistake, that we move away from the object the first thing we do. The next thing is that we need to describe how and what affects the object. So not just write an object, but try to just do verb and object and see how it actually connects. You get that connection. Now, the next thing we're going to talk about, and I think we'll do that in next video, is that if we look at every single possible cause, like I mentioned earlier, if you remember, that we want to do on level 1, we really want to keep it open and come up with every possible cause we can think of connected to the object that could be possible to do. But if we do that on level 2 and 3 and 4, what you're going to get is an FMEA. You're going to see every possible failure mode on that object. And how's that different than a root cause? So what's the difference between an FMEA and a root cause failure analysis investigation? Well, let's talk about that in the next video. And for now, I really appreciate you watching. And please subscribe. Click the little bell so you get updates. We try to do these about once a week. And we hope to see you here again. Thanks for watching.